Welcome to my chemistry project about bonding video. It's a video about bonding. Yeah, pause. First today, children, we're going to talk about ionic bonding. So, ionic bonding is where you have a metal and a non-metal that bond with they're oppositely charged ions and they bond. And so a way you can represent examples are table salt and iron oxide, because it's metals, which is the sodium and the iron, mixed with a non-metal, which is the chloride, and the oxygen and the iron oxide, oxygen. And they don't usually conduct electricity as a solid. They usually only conduct it, except for a few exceptions, they conduct electricity when they are when they are dissolved in water and it's late. When it's dissolved in water and if it's molten, as in liquid. Alright, and an example of this, like a way to represent ionic bonding, so let's say you have a Ford 350 Super Duty truck, a heavy metal, right? And you're going to crash into a Prius, right? The Prius is the non-metal, alright? So the pickup truck, right, is going, and let's say it has, man, how would this work? So it has, people in the bed, right, and the Prius has people in it, so it needs to bond. So the positively charged truck, metal, is going to hit the negatively charged Prius, so they collide, and then all the people in the bed, there's one person in the bed. The one person in the bed of the truck flies into the Prius through the windshield, and that way there's 3 people now in the Prius, and there's only 5 people in the truck. I don't think that works. Next, pause. Now we are going to talk about polar covalent bonding. Polar. So polar covalent bonding is when you have a pair of electrons and it's unequally shared by 2 different atoms. One atom will have a stronger pull, and so that way it'll have like a positive and a negative side, the molecule. This is with water. This is sort of why it has the surface tension going on. It's not as strong as a non-polar covalent bond because, and way you can remember it, it's a polar covalent bond because it pulls more of the electrons to one atom than the other. A way you can represent this in a model would be if you had a truck pull going on. So you have a Ford 350 Super Duty, right? Very strong, positive. And then you have your Toyota Tacoma 4-cylinder going on here, right? And you have like the hips and everything on this one, so it's very strong. And so you have let's say you have it's like a truck pull, right? So you have a rope, and you have, so we're gonna modify it. So there's how would this work? There's a so it's a big one, small one. So there's there's a flag in the middle, right? And there's the line. So it's sort of like tug of war with trucks. So there's 2 lines. It's 2 lines, right? So the guy in the so they're about to start bonding. So they both hit the gas, right? And they start flooring. You hear the Toyota going, and then you hear the Ford going, then it goes off, and it pulls more of that rope, the flag closer to its side. Its electron cloud. It pulls that flag closer to its side. Do you understand what I mean? Like there's the 2 lines, the flag, and it pulls and it goes, and it goes more towards that side instead of the Toyota Tacoma side, because the Toyota, for God's sake, pause. Did you play? Is it playing right now? The video's wrong. Alright, so we're going to talk about non-polar covalent bonding now, alright? So it's where 2 atoms share a pair of valence electrons equally. Like it's the equal distance from their electron cloud. Unlike polar covalent bonding, it would be a matched truck pull. Like let's say a Ford 650 with another Ford 650, right? The electron which we're going to call the flag in this scenario, the electrons that they're sharing the pair. So let's say there's 2 flags because they're so big, so you need 2 ropes to hold it, right? So you have 2 valence electrons in the middle, and it's shared equally because they can't pull each other because they have equal engines and stuff like that going on. You know what I'm saying? All right. It's very strong bond. It requires a great amount of energy to break it, such as a turbo or an illegal nitrous in your engine to beat the other forward. Hoo-yah. And then, yeah, it's equally shared electrons throughout both atoms, or trucks, or atoms, or ADAMS, Adam. Adam. And so an example of this would be like oxygen and hydrogen, the di elements where there's 2 elements in each molecule naturally, like oxygen, how it's O2 naturally, not O, and they have non-polar covalent bonds. It's very difficult to separate 2 oxygens. And I'm gonna pause it there. All right. So out of the 3 suggestions that we had to choose from, I chose hydrogen bonding because I couldn't find anything useful on metallic bonding. So hydrogen bonding is not really a bond. It's more like magnets when you think about it, because it's between 2 polar molecules or 2 molecules where there's hydrogen in those molecules, and they will pull towards each other to hold all those molecules like closer together. So this is sort of like again, water. Water is a good example for everything. Everyone loves water. I have my water right here in my Sherwood Warriors cup. I'm not a girl either, don't worry.
Sure.
Shut up. So, it's between molecules, not atoms, and with water, that's why the surface tension, because there's sort of like hydrogen bonds going on. They're attracting to each other and holding atoms together. It makes the boiling point for water very high because, you know, the water atoms don't want to leave each other when they get hot. So that's why the boiling point is high, because then when it gets really, really hot, then they're like, oh, whatever, and they go. So a way we can represent this with vehicles again is, let's think about this. So it's not a real bond. So an unfair bond, I guess we could say it. So we could say a Prius versus a Dodge Ram 3500, right? So we have the Prius, and we have the Dodge Ram. Wait, no, that wouldn't work. Hold on. So it's not real bond. All right, this will work. So we have 2 molecules, right, that both have our hydrogen in it, but we're going to say a V8 engine as our hydrogen, right? I think I know what I'm talking about. Not sure, don't have a car. So they both have V8 engines, which is going to be the hydrogen that bonds them together. And so the reason they're held together is because there's a Prius with 2 ropes tied in between each truck. But once it gets hot and the 2 trucks start flooring it, right? And with their V8 engines, they start flooring it and it gets hotter and hotter, then they will break the Prius in half, because the Prius is a car for not manly people. Don't even want to call it a car. It's like a scooter.
It's like an Obama.
Stop, don't say that. Wow. Wow, I can't believe you said that. Oh. Anyways. Not supposed to talk in videos anyways. So, hydrogen bonds are very weak. They can be broken easily. As the Prius example, snap in half. Everyone's like, oh no, my Prius. Oh no, I'm gay. If you drive a Prius. And then, yeah, it's not a true bond. And bottom line for hydrogen bonding is it's hydrogen in molecules, and the hydrogen attracts to each other. It's not a real bond. All right? Thank you. God bless America, and have a great day. I love you all. Amen.